Hello everyone, welcome to my youth programming club. Today we will be solving another daily Leetcode challenge, and the challenge name is permutations. So, given an array of named nums of distinct integers, return all the possible permutations. You can return the answer in any order. So, first, integer array nums. All the elements in the array are distinct. Also, it is to be noted that the constraints of the problem are these. The length of the array is of the order 6, and the values of the elements in the array or the numbers in the array is from -10 to 10, and all the integers are given to be unique. So what we have to do is we have to return all the permutations of this array. This array, oh yeah, and this array will represent? This array will represent a number. So let's say its a size of array is n. Now, what will be the brute force way to solve this problem? It will be to generate all the permutations. Now, since maximum value is size of the array is given to be 6, its maximum value is 6. So the number of permutations will be 6 factorial. I hope all of you know these concepts that for a n-digit number, let's say this is a 4-digit number. And let's say you are given 4 digits, A, B, C, D. Now for the first position, we are having 4 choices. For the third one, we are having 3 choices since one will be used here. And for the second position, this third position, we will be having 2 choices since already 2 choices will be used here. And for the last one, we will be having only 1 choice since 3 of them will be used in these positions before this position. And so the total number of permutations will be product of these, which is nothing but n factorial, or say 4 factorial. So I hope it's clear to you. So we will generate all the permutations, and 6 factorial is lesser than 10 raised to power 8 operations allowed in 1 second. Let me quickly change the slide. Those of you who do not know how the time complexity accepted solution varies according to input size. I will provide a link of an article describing this concept. You can explore that article, and then you will be able to know what I'm talking about here. That one in 1 second, only 10 is to power 8 operations are allowed. If your program is getting equal to or greater than these number of operations, then you may get a TLE. So here 6 factorial will be lesser, very much lesser than 10 is to power 8. So you need not have to worry about this brute force solution, and it will be accepted. The question arises how you will be able to generate all the permutations. Let's say you have to form a 4-digit number, and you have been given A, B, C, and D as input. These numbers you will be using to form the permutation. Now let's say now this itself is a permutation. Since it is an arrangement of numbers, so this array states also represent a permutation. So what we will do is, let's say we fix the first number as A. Now for first number we were having 4 choices. Among 4 choices, let's say you selected A here and you fixed this part. Now remaining choices are these. Now let's say you have now decided to fix the second position. Now for the second position, what you can do is currently the number at the second position is B. So you can swap B with these two values to get the number at position at this position. Let's say you swap B with C, then C will come here and B will come here, and now your position pointer, let's say a pointer is pointing first, it was pointing here, then it came here, now it will come here. Now since these digits till these positions you have fixed the digits for the permutation. After these positions, these two positions are being fixed, only you have been left with these. So currently your position pointer will be pointing here, and for all the possible values from this value, including this value to the right hand to its right hand side, you will one by one swap all the values with it, and those will generate new permutations. So a permutation, let's say you decide to swap this value with it itself only, then this permutation will be generated. Let's say you decide to swap this value with this value, D, then your this permutation will be generated. I hope it's been clear to you. What we are doing is we are fixing a position. After that, we are moving to our next position, and from all the positions from this next position to further all the positions till the end, you will be swapping these values with this position, and it will generate all the permutations that you are required. For example, let me take another example. Let the example be 1, 2, 3. Now you are at this position. You can swap 1 with 2, 3. So and also with 1 itself. Now if you swap 1 with 1 and 1 with 2 and 1 with 3. If you swap 1 with 1, it will be generating this number. Let's say now you have fixed 1, so you are left with 2 positions. Now your pointer will come here, Now you will decide how you will be swapping these two. Now, if let's say you decided to swap this with 3, now your number will be looking like this. Now, since here only any, we do not have any other choice. So this will be your current permutation. 1, let me quickly change the color. 1, 3, and 2. Similarly, you will be generating all the permutations by deciding which number we will swap with the current position that the pointer is pointing to. So the pointer will do a single iteration from left to right, and for each iteration, let's say pointer is pointing here currently, then all the values including pointer's current location and till the end of the number array given, you will be swapping these values one by one, and according to your swap decision, permutations will be generated. So I hope you are able to understand till here. Now let's move to the coding part. You will be able to understand it in a much clearer way. So I forgot to mention what will be the time complexity of this solution. It will be nothing but n factorial. And since 6 factorial, maximum time complexity can be 6, maximum number of operations can be 6 factorial, so it will get accepted. So let's move to the coding part. So what we have done here is, this will be the final result containing all the permutations of this number array, and we have made a function find permutations. This is nothing but a depth first search. Since we are going till the end, we are going till the very much end of this branch. So this is a DFS. So this find permutation function is a DFS, depth first search. Those of you who are new to DFS, I will provide a link for DFS. What we have done is, initially we have checked what is the size of the nums array, and if the that index that is iterating from left to right, we call this as start index. It will be going from left to right till the end of the array. If it happens to be equal to the length of the array, if it has reached the length of the array, then when we have got our permutation, and we will simply add that permutation to the result that is to be returned by the main function. So how we will be populating the permutations? What we will be doing is, we will be swapping the values inside the this given nums array itself. After fixing a position, we will start from that position, and from that position, the current position is start position, and to the very end of the array, we will be swapping these values. And once we have done swapping with these values, the nums array will be changed here. Nums array will be changed because of the swap operation. Now, this swap operation we are performing for the current value of the left pointer that is being that will iterate the nums array from start index to very end. Since the current state of the nums array will be changed, so to make the state of nums array same again, for further for further values of left pointer, we will again swap the values. So this is for the current value that is left pointer is being pointing this swap operation. Now since our array should not have been changed for the next the value that we will consider to which the left pointer will be pointing, so that we are swapping it again. Basically what we are doing is we are backtracking. Let's say at a particular instance we reached this value, then we will backtrack from here, we will come back from here, we will come back from here, we will come back from here, then we will explore this branch, then we will go till the depth of this branch. When we will hit the end of the array, then we will add that permutation and we will be coming back from those choices, and at each choice we will be making the state of the nums array same similar to the original state before it have been changed while exploring this branch, and then we will explore another branch. So this is nothing but backtracking. So this, again making the array similar to what it was before this operation was done. This recursive call for the find permutation function was made, is to be done so that we can discover other branches also, and it will give us correct answer. So those of you who are new to backtracking, I will provide a link for article describing backtracking, and you can explore their article. Then you will be able to understand what we are doing here in much clearer way. So this is nothing but a swap operation. This is the swap function that I have made to swap the values in the nums array. So at a given index, I am swapping these two values at index 1 and index 2. What will be the index 1? Index 1 will be the value of the start index. That is the current value that this start index will be pointing to. So according to the values of the start index, your number of choices to be considered for swapping will be decreasing. Now let's say you were making a 4-digit number. For this first position, you were having these 4 choices to make a swap. Then let's say you are at this second position. Now you will be having these 3 choices for making a swap. So accordingly, the number of choices for making a swap will decrease. It will be having first position will be having 4, then another will be second will be having 3, then third will be having 2, and finally the last will be having 1. So it is nothing but 4 factorial, and so the time complexity of solution will be of n factorial, and it will get accepted. Now let's discuss another approach for this problem. Another approach. Now here what we have done is start pointer, the start index, was iterating over the array from left to right only once. Then we were checking how many positions we are left so that we can make a swap. So instead of checking how many positions we are left, we can check. Let's say we will consider this position will be having 4 choices. Let's say there were 4 numbers A, B, C, D. Now this position was having 4 choices. Now let's say it made a choice of selecting one of them. It was A. Now A was at the index. This was the nums array given to you. Currently I am considering the elements to be alphabets. So this was the nums array, and these were the indices 1, 2, 3, 4. 0, 1, 2, 3. since it's a zero based indexing. Now, for this particular position, now let's say you are considering how many number of choices you are having currently here. Now, excluding the choices that you have made in the previous decision of your choice of numbers, uh, you will having all rest of the choices. So excluding this index 0, you will be having these three choices. So you will be having three choices. Now let's say you pick C. Now excluding this second index, for this position you will be having these two choices. It will be B and D. So it will continue in this manner. Now how will you know which indices are previously picked while forming permutation? Since the size of the array at max will be 6, since the nth value is given here to be, num's length is given here to be 6, maximum value will be 6. So integer variable, let's say x, will be containing 32 bits. And among these 32 bits, you can use 6 bits to represent, let me quickly change the color, to represent the indices that are previously picked while forming the permutation. So our challenge of knowing which indices are being picked previously, have been picked previously while forming the permutation is solved, and thus we can consider for each position we can consider n choices itself, and we will exclude those choices which have been previously made from these n choices with the help of 32-bit integer variable. And this concept of uh, storing the entities in the bits of a number is called bit masking. Those of you who are new to bit masking, I'll be providing a link for article describing this concept, bit masking. So you can explore that article, and then you will be having a clear understanding what we are doing here. The rest of the solution will remain pretty much the same. Uh, there will not be there will not be major changes, and the time complexity of the solution will also be of n factorial. So let's quickly dive into the coding part of this approach, and then you will be able to understand it in a more clearer way. So let me quickly comment it out and uncomment the second approach. Yeah. So this is the second approach. What we have done is these things are pretty much the same. What we are adding extra is we are taking first argument as the nums array, which will be given to you. This is the list that is to be returned, that will contain the permutations. So this is the check mask. Check mask is for checking which indices are included. This is for checking which indices are previously included in the permutation being formed currently. Pardon me if some spelling is incorrect. I hope it does not affect your understanding of the problem. So this will be our current permutation that we will be forming. So in order in that swap approach, we were using the nums array itself. Since we are not using the nums array itself to store the current state of the permutation, we will be using a extra space to store the current permutation. So what we will be doing is, for each position of the current index, you will be having n choices, and among n choices, you will be excluding those choices. This filter will do. What will this filter do? Filter of excluding those choices which are previously made while making current permutation. So if the current index value, the bit representing the current index value is not set, then we are fine with it. So the current index is not exploited as a choice for the current permutation being formed. Then we will add the element at the current index to the current permutation, and this will and we will call we will make a recursive call, and before making a recursive call we will set that index bit representing that index value in the check mask, so that it should not be repeated again. And then we will making a recursive call, and this is the backtracking part. You will be making the state of current permu vector or say list same as before, so that you can explore other choices, or say that will lead to separate branches in the recursion tree. What is the recursion tree I am talking about? This is the recursion tree that we have just uh, that drawn here. This is the recursion tree. We will be making the state of the current permutation list, or say array list, same as before, and so that we will be able to explore other branches. I hope it's clear to you. And at last, when all of the indices, all of the bits representing the all of the indices in the nums array are set, then we can say we have reached the end. If all the bits representing the indices of the nums array are set, then we can say that we have formed a permutation, and we will return. We will return. So this is pretty much it. These both were the backtracking approaches, but one was using a swap function to make the permutations, and another was using bit masking along with extra space, and the overall space complexity will be O of n. N is the size of the input, n is the size of the nums array that you will be given. So space complexity will be this. space complexity. Also, this much space will also be used by the recursion stack, since you will be forming a n-digit permutation, and each branch length will be n. And since you are doing a DFS, only when one branch exists, another branches will not be existing in the recursion stack. And as soon as we are done with that branch, then all the values of the recursion stack will be popped out and next branch will be explored. So time complexity is off. And so thanks for watching. Thank you.